Another key process that happens in the troposphere is the process of acid deposition. It's commonly known as acid rain, although we will see that it's not only rain, it's also smog and it's also fog and sleet and snow, and it not necessarily is wet deposition. Besides rain, you can also have dry depositions, particles depositing in the surface of the earth. So the word acid deposition reflects better what the processes we're going to be talking about are about. The pH of unpolluted rain is typically, although it does range depending on the area, in the slightly acidic, around 5.7. And that is because of the presence of CO2, which is a mildly acidic gas. When you have the components in the atmosphere, then that pH can decrease quite dramatically, and that pH of the rain can become much more acidic. And what two compounds primarily participate in that reducing of the pH, in that rain becoming so highly acidic? Well, sulfur dioxide and nitrogen oxides, which are mostly associated with industrial processes, and also in the case of nitrogen oxides with traffic. Once that sulfur dioxide and the nitrogen oxides are in the atmosphere, they can interact with water molecules and form nitric acid and sulfuric acid, and form clouds and eventually precipitate in the form of rain or snow or ice. And then we talk about wet deposition. But if they are large enough, sulfur dioxide, for example, is large enough, they can deposit down without the associating with rain, deposit down on the surface of the earth, or they can get adsorbed in the surface of a small particular matter in the air, and again deposit on the surface of the earth, and we call that dry deposition. So wet deposition is associated with rain, snow, ice, and dry deposition is associated with either the compounds sulfur dioxide depositing into the surface of into the land, or getting adsorbed in the surface of small particles floating in the air, and then deposit on the ground. Rain chemistry. What sort of chemicals you have in rain, and what sort of, are they acidic and basic? Well, most of the compounds you can find in rain have an acidic character. You've got CO2, which I've mentioned before, but you also have, for example, carbon disulfide or dimethyl sulfide and carbonyl sulfide, which are associated with microbes, bacterial activity, especially in submerged soils, wetlands, anoxic conditions, lack of oxygenated conditions. And you have also nitrogen oxides. There is a small amount of nitrogen dioxide naturally in the atmosphere, but most of it comes from fossil fuel or biomass combustion. And you also have, for example, sulfur dioxide. Again, there's a small amount of sulfur dioxide naturally in the atmosphere, but most of it is associated with industrial processes or mining activities. For example, the extraction of certain metals from their ore, like lead, which you can find as a sulfide, or fossil fuel combustion. And all those compounds contribute to the pH of the rain to be mildly acidic. And against it, you have compounds like, for example, the carbonate anion that is a basic compound, or for example ammonia, which well, there is a certain amount coming from microbial activity, but mostly it's associated with the use of fertilizer or animal manure, and those are basic compounds. They give the rain a more alkaline pH. One of the key components of acid rain, of acid deposition, is nitric acid. The other one is sulfuric acid. So nitric acid, how does it form in the atmosphere? Well, there are quite a few processes that increase the level, well, that produce nitric acid in the atmosphere. You've got the release of nitrogen monoxide radicals that can react with ozone, and then with the hydroxyl ion, and with peroxide ions to form nitric acid. And these are daytime reactions. They happen during the days that are catalyzed by sunlight. But you also have nighttime reactions, and we mentioned these reactions when we were talking about the removal of photochemical smoke chemicals in the atmosphere, which is the reaction of the nitrogen dioxide radical with ozone, the destruction of ozone in the troposphere to form this nitrate NO3 radical, and that eventually reacts with other chemicals that are typical from a photochemical smoke episode, and that are typically associated with traffic to form nitric acid. And I think I mentioned that when we were talking about photochemical smoke, that the removal of nitrogen dioxide from the atmosphere, which is a way that to stop a process of photochemical smoke happening, does have the problem that nitrogen oxide, that those NOx are converted into nitric acid, which is in itself a problem because it's associated with acid deposition. So once nitric acid is formed in the atmosphere, how does it get removed? Well, you can have a wet deposition in which the nitric acid mixes with molecules of water and forms cloud that eventually it rains. Or you can also have dry deposition in which the nitric acid gets adsorbed in the surface of aerosol particles, so very small particulate matter, and deposit in the ground in a dry form. Additionally, it can sometimes react with ammonia in the atmosphere. Where can you get the ammonia from in the atmosphere? Well, typically would come from animal sources or agricultural sources, or animal urine, or the fertilizers which are rich in ammonia. And it reacts with nitric acid to form ammonium nitrate. And this ammonium nitrate is a hydrophilic salt, so it makes it repels water molecules, and it makes water condense into droplets that eventually form clouds, and well, they come out as rain. So as you can see, a couple of different processes that will mean that the nitric acid it's deposited in the ground. The other key component of acid deposition is sulfuric acid. And how can you form sulfuric acid in the atmosphere? Well, there are a couple of processes involved in the production of sulfur dioxide, which is the precursor with water of sulfuric acid. On one hand, you have these sulfur-containing species that come from reduction processes, microbial activity in low oxygen level areas. This methyl mercaptan, dimethyl sulfide, dimethyl disulfide, that's sulfur species that when released into the atmosphere and in contact with the hydroxyl radical can produce this sulfur hydride radical. Then again, reacting with oxygen and reacting with ozone form the molecule of sulfur dioxide. And these species form here, especially this one, is quite stable. They can last for months, even sometimes years in the atmosphere. And once the sulfur dioxide is formed, it can react with the water molecules to form sulfuric acid. This is the structure of sulfuric acid. Another way of forming sulfuric acid in the atmosphere is by direct emissions, direct release of sulfur dioxide. For example, from burning of coal with high sulfur content. And it forms various oxidized species, these peroxide species, and eventually interacting with the peroxide radical, and with the presence of nitrogen monoxide that you also have in the atmosphere, you produce sulfuric acid, or here sulfuric acid. And sulfuric acid is an oxidizing agent, and it's also a strong acid. So it contributes to the acidity of the decrease in the pH of rain. So as a summary, sulfur dioxide can be released directly from anthropogenic sources, although there are also natural sources of sulfur dioxide, as I will discuss later, for example, volcano eruptions, or by oxidation of sulfide compounds from microbial activity, and form with the help of the hydroxyl radical, and with the help of the peroxide radical or ozone, form sulfuric acid, which then can interact with water molecules and form clouds, mist, rain, or even snow, sleet, etc. So once sulfuric acid is formed, how does it get removed from the atmosphere? Well, as I mentioned before, it can interact with water molecules and form clouds, and then it deposits. We are talking about wet deposition in the form of rain or hail or snow. And it can also interact with ammonia in a similar way to what happened with nitric acid. It can also interact with ammonia to form this ammonium sulfate and ammonium hydrogen sulfate salts, which then help the condensation of water vapor and form clouds. And these species are large enough, these ammonium salts are large enough that they themselves deposit without needing to be associated with water. They deposit on the surface of the ground. So you have wet deposition and also a dry deposition.